A quick trick to find complex roots, in this case of the cube root of negative 27. But the trick will work for any root of any real number. Math can be easy. If you know the tricks, it can be real easy. So we're going to find three values of the cube root of negative 27. Yes, this little 3 indicates that it has 3 cube roots. Most people know the square root of 4 can be plus 2 or negative 2. Well, square roots have 2 roots. Cube roots have 3, fourth roots have 4, and so on. The trick is to find 1. So there are 3 cube roots, and they're all the same distance from the origin. So we're going to have a graph with an x-axis and an y-axis, an imaginary axis. Imaginary don't really mean imaginary in that sense we're accustomed to. It means imaginary number, which is not all that imaginary. They have a purpose. So here the distance is 3, since 3 is the cube root of 27. Don't worry about the negative just yet. We'll get to that. One root is on the horizontal, a distance 3 units from the origin in a negative direction. This root becomes our starting point and is located 3 units out and pi units around, or simply negative 3 on the x-axis, or on the horizontal axis. Since there are 3 cube roots, the cube roots are located on a circle of radius 3. We get that from the cube root of 27, and are equally spaced. So now we divide 2 pi by 3. And if you want to work in degrees, it's okay. You multiply, divide 360 by 3 and get 120. And find the points on the circle. So the form of our solutions is going to be r, which is the 3 in this case, times the sum of the cosine of the angle plus I sine of the angle. And now we'll put it right on the circle and at the right angle. And in this case, our angle is going to be pi minus minus pi over 2 pi over 3, or pi over 3, and pi plus 2 pi over 3, or 5 pi over 3. So the answers are 27 to the 1/3, that's our 3, cosine pi plus I sine pi. Now here, the cosine of pi is -1, so this is 3 times -1. The sine of pi is 0, so this is simply -3. Here we get 3 times the cosine of pi over 3, which is 1/2, plus I times the sine of pi over 3, which is I, the square root of 3 over 2. And here we get the cube root of 27, which again is 3, cosine 5 pi over 3 plus I sine pi over 3, which is 3 times 1/2 minus the square root of 3 over 2. Now, some of you probably have looked and said, wait, these are conjugates. It's conjugate pairs. Remember, when you use the quadratic formula, you get conjugate pairs. So does it always happen? And the answer is yes. Once you get one complex number, the other one is a conjugate pair. So whether you start at 0 or you start at pi, you go a distance in one direction, you go in the other, you're going to be on the same circle, and the 2 points are going to be stacked one over the other. So the trick is to determine the radius from a real number root and start at 0 for a positive root and pi for a negative root. Divide the circle by the number of roots and space the roots equidistantly around the circle. Notice the complex solutions will always be conjugate pairs, so if you find one, you can just write down the other. Well, thank you for watching. Please consider subscribing to the channel. I have many others and more are on the way. There'll always be additional videos. I hope. I hope I can keep on making these. But thank you.